Alright, this is part 2 of our lesson on arc and angle relationships. In this video, we're going to focus on solving problems like number 12 here, where we have an angle that is inside the circle and intercepting two arcs. And there's going to be a formula for that. That's what we're going to focus on the most. Alright, when you have an angle that is inside the circle, not at the center, but off center, okay? You have this sort of double angle, but both of these angles are the same, so I'm just going to call it theta, even though it would be the same over here. Anyway, when you have these lines intersecting, forming this angle theta, it's also forming two intercepted arcs on the circle. Alright, I'm going to call the bigger one x and the smaller one y, though it doesn't really matter which one is the bigger one or the smaller one. The relationship between the angle and the two arcs is this. The angle is going to equal arc plus arc divided by 2. Basically, this angle is the average of these two arcs. Alright, arc plus arc divided by 2. So when you look at number 12, that's the situation that we're in. Alright, this angle 1, I'm just going to go ahead and call it theta. Alright, I like to call the angles theta. The angle is going to equal arc plus arc divided by 2. So 140 plus 116 divided by 2. And this is what we're supposed to be finding, the measure of angle 1, which I'm calling theta. So I'm just going to put this in the calculator. 140, 116. $128. Okay, 128 degrees. Alright, number 12 is as simple as that. Alright, where is number 13? Okay, got to get to the next page. Now, number 13 is not like the one we just did. Number 14 is back to that again. Okay, but this one is slightly different. Alright, when you have an angle outside of the circle, that's a different angle relationship. Alright, outside, we have a big arc and a small arc, and this time it does matter, big arc and small arc, because the relationship is this: the angle is equal to the big arc minus the small arc divided by 2. So look at the similarities and differences. When the angle is inside the circle, it's arc plus arc divided by 2. Alright, we'll give you the angle. When the angle is outside of the circle, it's arc minus arc divided by 2. And of course, it has to be the big one minus the small one. Otherwise, it'll give you a negative number. Okay? And when the angle is right on the circle, then of course that's an inscribed angle, and the angle is half the arc. And if you wanted a little formula for that, you could say the angle is equal to the arc divided by 2. You know, if x here was the arc, right, the angle would equal arc divided by 2. So really we have three relationships, right? On the if the angle is on the circle, the angle is half the arc. If the angle is inside the circle, the angle is arc plus arc divided by 2. And if the angle is outside of the circle, the angle is arc minus arc divided by 2. So you just need to memorize those three situations. I guess technically there's a third situation that we learned. Please don't forget that when the angle is at the center of the circle, then the angle and the arc are equal in measure. So a really simple formula would be theta equals x when it's at the center. Alright? So really there are 4 situations, including this one. So back to business. So number 13 Which one of these four situations are we dealing with? It's this one. Okay? Number 13, we have the angle that's outside the circle. So what we have is the circle is being divided into these two arcs. I have one arc that's doing this, and I have another arc that's doing this. Alright, it just so happens that together they make the entire circle, but it still follows the same rule. Angle equals big arc minus small arc divided by 2. So we need to know what these two arcs are. Since together they make the entire circle, the thing to do is to subtract from 360. Okay, to find this one. So if we do 360 minus 243, that should give us the fuchsia arc right there. Alright, I'm sorry, 360 minus, what was it, 243. Okay, that is 117 degrees. Okay, so that tells me that the fuchsia arc is 117 degrees. So when I use that formula, it's going to be like this then. The angle, and I'm just going to go ahead and call it theta instead of angle 1, alright, because that's what I like to do, but the angle is going to equal the big arc, 243, minus the small arc, divided by 2. Okay, 243, 117. $63. Alright, so that's how you do number 13. Number 14 is the same thing. I'm going to call this angle theta instead of angle 1. But just like before, the angle, wait, okay, I mean I said it's the same thing, but it's not the same thing as number 13. It's the same thing as number 12. Okay, we have the angle inside the circle. So please remember, that's not what I wanted. I said, please remember that when the angle is inside the circle, the relationship is the angle is equal to the arc plus the arc divided by 2 when it's inside the circle. Okay, so this angle will equal the arc plus the arc, so 120 plus 98 divided by 2. $109. Alright, so there's number 14 for you. Okay, now you have to be a little bit careful with this problem because this angle is off to the side. Okay, so this problem will be a little bit tricky. So if I go ahead and do these arcs, the angle that I'm supposed to use is this angle right here. Okay, now this angle is not the angle that I'm looking for, but if I had this angle I could find the other angle. So let me go ahead and find this angle, but please understand that when I find angle theta, that will not be my final answer. So just like before, to find angle theta, I go like this. When it's inside the circle like this, the angle is equal to arc plus arc divided by 2. So that's 53 plus 41 divided by 2. Okay, so that is 47 degrees. Now, again, this is not the final answer. So that tells me that this angle right here is 47 degrees. Alright, let me go ahead and put it in there. So this is 47 degrees. Now, we want to find the angle that's right next to it. Now, here's the key. Even though this is not a diameter, still, there's something I can do right here. Look at this. Even though this is not a diameter, it is a straight line. Okay, and if you take a straight line and you split it up like this, okay, any straight line is going to form a total of 180 degrees. Alright, it takes 180 degrees to make a straight line like this. Alright, that is 180 degrees. So, to find angle 1, all I really need to do is subtract 47 from 180. So if I do 180 minus 47, okay, so what's that? 133? Okay, so that's going to be the measure of angle 1. Okay, it's going to be 133 degrees. And check it. You know, these angles form a straight line together. Together, they make 180, so it makes sense. Okay, so that's it. That's the answer to number 15. So the measure of angle 1, alright, I had to go ahead and actually use angle 1 this time. But the measure of angle 1 is 133 degrees. That one was a little tricky. Alright, where's number 16? Here we go. Okay, this is another problem similar to the one I just did. It's a little tricky because, again, this 129 is off to the side. It's not the right angle. It's not the correct angle. Alright, the angle that we need to do the formula, it needs to be this angle right here. Okay, but based on what I just taught you on the previous problem, again, you see that this is a straight line. So how could I find this other angle over here? I can subtract from 180. So what I'm going to do is, off to the side somewhere, I'm going to do 180 minus 129. Okay, so that's going to be, what, 51, I think? $51. Okay, so that means this angle over here is 51 degrees. Now, see how these all line up? The X, the 51, the 35. That's why I had to use the 51. I couldn't use the 129. It has to be the angle that is forming these two arcs. Alright, so anyway, now that I have the correct angle that I really needed, we can go ahead and use the formula. Why do I keep picking on that? We're doing this formula right here. When you have an angle inside, it's arc plus arc divided by 2. So, now notice, it's the angle equals arc plus arc divided by 2. Angle comes first. Okay, so what part of this is the angle that I'm talking about? It's the 51. So when I set this up and I say, okay, angle is equal to arc plus arc divided by 2. Alright, pay attention to what goes where. 51 is the angle, so I go 51 equals arc, okay, that's x, plus arc, that's 35, divided by 2. Alright, A lot of kids will automatically put the x over here by itself because they want to go straight to the solution. But that's wrong. It's angle equals arc plus arc. Alright, the x and the 35 have to be here. So it's a question of how do I solve this equation? Well, you see this denominator of 2. You want to multiply by that. So let's multiply both sides of the equation by 2. That way these 2's will cancel each other out. 2 times 51 is 102. So 102 is equal to x plus 35. Then we're going to subtract 35 from both sides. Okay, let's see. 102 minus 35, you say. $67. Okay, so 67 is equal to x. Alright, and that's what we were supposed to find out. Alright, so the trickiest thing right there was, first of all, understanding that we're not going to use the 129 because that's not inside of the x. Okay, we needed the 51 that lines up with the x and the 35. Okay, that was number 16. How about number 17? Alright, number 17 is almost like number 16. So if you just watched me do number 16, you should be able to do number 17 by yourself. So please stop the video and do number 17 by yourself. Okay, it's the only way to learn. Watching me do another problem is not going to help you. Do it on your own. Okay, so please understand this, my good people of the world. We have these arcs. Alright, we've got the 25 and we've got the x. These are the two arcs. Alright, now the angle that forms that is this angle. See if I sort of connect these, alright, making the bow tie. Alright, do you understand that the angle that I really want is this angle right here? Alright, that I just called theta. The 137 is not the correct angle that I really want. So the first thing I need to do is figure out what that fuchsia angle is, what theta is. And again, the way I do that is I recognize a straight line when I see one. And anytime you have a straight line like this one I just drew in green, if I take that line and I split it up like this, together these angles make 180 degrees. Right? A straight line is always a total of 180. So all I really need to do is subtract from 180. So if I do 180 degrees minus 137 degrees, that's going to be 43 degrees. And from there we will just execute the formula for this situation. Angle equals arc plus arc divided by 2. So the angle is 43 degrees that we want, so that means 43 is equal to x plus 25 divided by 2, arc plus arc. So it's just a matter of solving for x. So when you have a fraction and you want to solve it, just multiply by the denominator. That way these 2's will cancel each other out. So this is going to be 86. So we'll have 86 is equal to x plus 25. And then we'll subtract 25 from both sides. So that's going to give you x is equal to 61. Okay, so that's going to be your answer. Okay, number 18. In the diagram shown, M is tangent to the circle at point S. Find the measures of all the numbered angles. Okay, so you really need to get your highlighter ready, because with all of these angles and arcs mixed up into one problem, it's really important that you highlight one angle at a time and match it with the correct arc. Otherwise, you're just going to get confused. So I'm going to try to go in order. I'm going to try to find angle 1, angle 2, angle 3, and angle 4 in that order. Let's see how I do. So I'm going after angle 1. So I'm going to highlight that. So please understand that angle 1 is this angle right here. Okay, this is angle 1. Okay, now angle 1 has an intercepted arc that I want to focus on. Okay, this is the arc intercepted by angle 1. It's this whole thing that goes from here to here. Now, the relationship that I'm dealing with is, let's see, it's this relationship right here. This is an inscribed angle. Okay, it's on the circle. So the angle should be half the arc. This is the situation that we're dealing with. Okay, so how big is this arc? Well, you see that this arc is composed of two smaller arcs, 70 and 124. So I'll just add those together, of course. So that's going to be, well, 20 plus 70 is 90. So this will be 194 degrees. All right, that's this whole arc. Now, like I said, the angle then should be half of this. Okay, so angle 1 is 194 divided by 2. So I'm doing half. And that gives me 97 degrees. So I've just found angle 1. Angle 1 is 97 degrees. Okay, I'm just going to squeeze it in there. 97 degrees. Now let's get a little list going over here off to the side. So the measure of angle 1 is 97 degrees. And I'm going to need the measure of angle 2, the measure of angle 3, and the measure of angle 4. Okay, now if I have the measure of angle 1, I should be able to find the measure of angle 2 immediately, because angle 1 and angle 2 together form this straight line over here. Okay, do you see? Angle 1 and angle 2 together make this straight line. And we know that a straight line, if you split it into two angles, the two angles have to together make 180 degrees, just like a semicircle. So I should be able to subtract 97 from 180 to find angle 2. Okay, and you'll notice this comes up over and over and over again. So let's do that. If I do 180 degrees minus 97, that should give me the measure of angle 2. That's 83 degrees. Okay, so angle 2 over here is 83 degrees. Okay, let's add that to the list. Okay, that's this angle right in there. Now, how am I going to find the measure of angle 3? Well, to find the measure of angle 3, I'm going to erase all the stuff that I did so far. Alright, and once again, let's highlight what we're looking for. We're looking for angle 3. So please notice that angle 3 is formed by these two chords. Okay, because this is angle 3 is right in here. Okay, that's angle 3. Now, so we are dealing with this situation where we have an angle inside of the circle, all right, formed by these intersecting lines. And we know the relationship between the angle and the two arcs that it intercepts. Namely, angle is equal to arc plus arc divided by 2. So if we knew the arcs, I could find the angle. Now, I know one of the arcs, don't I? Okay, I know this arc down here is 70. So if only I knew this arc up here, then I could do the formula. Well, I'm pausing so you can think about how to find this other arc. And I'm hoping that you notice we have all the other arcs. There are only 4 arcs showing on this circle, and we know the other 3. So if we know the other 3, how could I find the missing arc? You guessed it, we will subtract from 360 degrees. Okay, so if we do 360 and we subtract these other 3 arcs, so 360 minus 124 minus 70 minus 110. That should give me arc VS over there. That should give me the missing arc. You could type it all in just like this. That leaves 56 degrees. Okay, so that means arc VS over here is 56 degrees. So let's see, 56 degrees. Now we can do the formula, okay, using the angle and the 2 arcs. So remember, the formula said this: angle, in this situation, angle is equal to arc plus arc divided by 2. So in this case, the angle is the measure angle 3. Okay, so angle 3 there is equal to arc plus arc divided by 2. So that's 56 plus 70 divided by 2. $63 degrees. Alright, let's go ahead and record that on our list. Alright, so we only have one left to find. Okay, now we just discovered that the angle 3 here is 63 degrees. Right? Yeah. So now we need to find angle 4. But once again, finding angle 4, now that we have angle 3, is easy. Alright, I can forget about all this other stuff. I don't need it anymore. Because all we need is the fact that we have a straight line. And a straight line makes a total of 180 degrees. So if I take this straight line and I split it up into angle 3 and angle 4, these are supplementary. They have to add up to 180 degrees. So I just need to subtract from 180 to find the rest. Okay, so what I'm trying to say is, if I do 180 degrees minus 63, that's 117. Whoops, messed up the 7. Alright, we found all 4 in order. Okay, that was number 18. Is there a number 19? Is there another one down here hiding somewhere? I don't think so. Let me just zoom out to be sure that I'm not skipping anything. Alright guys, I think we have finally reached the end of this lesson. Yep, we did it all. Okay, I really hope this video was helpful to you guys, and I will see you on the next video.